So the first thing I want to kind of do is figure out how many coefficients there are. How many coefficients do we have on this one? So we got one in front of the first one after each plus, and one there, the fourth. One in front of the first one after each plus, and one after the arrow. I'm going to also point out a couple of pointers that help us to keep from getting kind of trapped where we change something and then it changes what we just did, and then we got to go back and make that change. When I see this magnesium like this is a free element. As is this hydrogen over here. And I want to do free elements. I like to do those last. All right. I like to do those last because if I change this number, it only affects magnesium. But if I change this number, it's going to affect both hydrogen and chlorine. And so if I save that for last, I might end up messing up some work I've already done. Okay. I also prefer to do the weird stuff first. Oh, I can never spell weird. It always feels weird to me. Is that right? Okay. So here's the ones that are not weird. Carbon, hydrogen, nitrogen, and oxygen. Anything besides those is weird. So if I'm looking at this and I'm trying to decide where to start, magnesium and hydrogen are free elements. I probably want to save those for last. So I'm probably going to jump on the chlorine first. It's not a free element and it's weird. Maybe I'll do the magnesium next, but I'd like to save that hydrogen for last.
So you're saying the free elements are not weird, so that's.
Oh, no, free element is, okay, so the two different kind of rules of thumb here. Free elements are found someplace by themselves. They're found someplace by themselves. So magnesium is a free element on the reactant side. It's not a free element on the product side. Okay. Then I also have the fact that magnesium and chlorine are both weird, as in we don't normally use them. We did the other one with it all had carbon, hydrogen, and oxygen. We'll see those over and over and over again. So these four aren't the weird ones. Then later we'll also learn to pick up on parentheses. So when I make this list, I'll just do this side, magnesium, hydrogen, chlorine as I see it. When I do this side, remember I want to keep the hydrogens lined up so it's easier to compare left to right. We got 1, 1, 1, 1, 2, 2. Now, even if I started with the magnesiums, they're already at 1, so I'm not too worried about them. I'd like to do this hydrogen last over here, or this chlorine next. But sometimes the answer jumps out at us. Does the answer jump out at you? What is it? All right, so you want to put a 2 right here, and that gives us 2 on both sides. And that's it. That's all there is there. We have the smallest whole number ratio of 1 to 2 to 1 to 1. And they're all the same. So notice if the answer had not jumped out at us, we would have started with the chlorines, put a 2 there. Those 2 would have changed, and we'd have been done in almost the same amount of time as if that answer jumped out at you. So the process will always get us there. It just sometimes Yeah, they are. They are. As I started doing this one, I was like, wait a minute, I'm trying to think of C18. We would have to be burning up there in the range of burning sugar. How many coefficients? 4. 1. So the numbers start off kind of intimidating, but it's not too bad. Matter of fact, the hardest number is at 3. That's the one that seems to give us the most trouble because it's in 2 locations. You'll notice oxygen is a free element, and so I'm going to save the oxygen for last. We don't have any weird elements, so oxygen I'm going to do last. I'm going to jump right into the carbon. How am I going to fix the carbon? $18 over here. So 18 times 1 gives me 18. Now I'm going to go ahead and do the math to show that this changed the oxygen count. But when I'm doing a combustion reaction, I usually don't do that first set of math because I realize I'm going to have to change it again later. So 18 times 2 plus 1 times 1, I got 37 down here. But we're going to end up having to change that 37 anyway. So let's jump on the hydrogens. How do we want to fix that? Another 18. All right. Because the 18 times 2 would be 36. And now my oxygen changes to its let's see, 3 times 18, 54. Great. Afraid I was gonna take my shoes off. Not on my toes. Let's see, 54 is a nice even number. So when I come over here, do x times 2 equals 54. X comes out to be 27. We put 27 here. I'm going to double check my ratio. And this is actually the part that makes me enjoy balancing equations. At first, it seems kind of problematic, but why I really like them is the sense of power I get when I'm on the test and I can answer these 2 questions. Is this the smallest whole number ratio? Yep, if one of them is 1, you can't reduce it, right? They're all whole numbers. And does it give me the same on both sides? So let's double check that real quick. 1 times 18 times 36, 4, 18, 36. Everything looks good. That is in fact 54. All right, so if that's the smallest ratio and I've got the same on both sides, the power in the feeling there is going, I got this one right. That's a really nice feeling on the test. When you can look at it and say, I got that one right. In fact, the place where most students miss these is if I ask for one specific number. So this one, it wasn't a problem. If I'd asked for the number in front of the CO2, getting it off of that 18 would have been fine. But the one we did before where we had to multiply by 2, I'd have had the wrong number when I had that initial one, if I didn't do the problem all the way out. All right, so let's get some smaller numbers here. Aluminum plus HCl goes to aluminum chloride plus hydrogen gas. Four coefficients. Two free elements. Two weird elements. If we start our process, we'll get there, but this one turns out to have the first of our kind of cheats, our first of our hints on how to speed things up. When I was a student, they called it the least common multiple. Now I think they call it the lowest common multiple. Right. And why I'm picking that as my skill is when I look at this problem, I see that up here I have the same, for every hydrogen, I need one chlorine. I need the same amount of both of those. This one comes in packs of 3, and this one comes in packs of 2. And so this is the kind of problem that they had fixed for a long time, but my grandma, she used to run into this all the time. Hot dogs would come in, the buns would come in packs of 8, and the dogs themselves would come in packs of 10. But she grew up in the Depression, and she refused to waste either meat or bread. And so she had to buy enough so that she had the same number of dogs that she had buns. And then she'd take all the rest and stick them in the freezer on her back porch. I was 16 before I ever had a hot dog that wasn't freezer burned. I remember going to the ballpark going, oh man, these are great. Everybody's going, oh, they're kind of terrible today. Oh, these are fantastic. I don't know what's special about it. I don't know what they did about it. But this comes in packs of 3. So the multiples of 3 are 3, 6, 9, 12, 15. And the multiples of 2 remember doing this? Way back a long time ago, maybe? Okay. All right, so where's my lowest common multiple? 6. So I need to get to where I have 6 of each one of these. I'm going to do that by putting a 6 here. How am I going to get 6 chlorines? Multiply this by 2. How am I going to get 6 hydrogens? Put a 3 there. Right. So I now have 6 hydrogens, 6 chlorines. Oh, I got 2 aluminums. No problem. I'll come back up to 2 there. So that trick speeds things up a little bit. That's our first little trick. Now, had we decided that we did not see that trick, we would have got to the same place. We would have come in, we would have put, depending on where we decided to start. So let's do the hydrogen last. So I would put a 3 here to fix my chlorines. Then I need a number over here so that when I multiply it by 2, I get 3. So I'll use 3/2. This gets me my ratio, but what's the problem with it? How do I know it's my ratio? These numbers are the same. What's the problem with my ratio? I have what? I have a fraction. Why can't I not have a fraction? All have to be whole numbers, the smallest whole number ratio. So my ratio is 1 to 3 to 1 to 3/2. but I need to go ahead and fix that. I've got a half on the bottom, so I'm gonna go ahead and multiply them all by 2. That becomes a 2. A lot of people forget that that's the 1 there. It has to become a 2. This one becomes a 2. This one becomes a 3. So now I get 2 aluminums, 6 hydrogens, 6 chlorines, 2 aluminums, 6 hydrogens, and 6 chlorines. You'll notice it's the same answer we got doing the trick. As long as you can handle dealing with this temporary